This part of the engine build series, I'm going to be degreeing my camshaft using a degree wheel, dial bore gauge, lifter. We're going to find top dead center of the #1 piston and set the cam degree wheel off of that, then go into the process of making sure our lift and duration or center line is as advertised on the cam card that came with the Lunati cam that I got. You do this, it's a double check system. Nobody's perfect, and the cam manufacturers, sometimes they might put the wrong cam in a box or it's ground off from the factory. There was a manufacturing error in it, and you want to make sure before you get your motor built that you're going off the proper cam specs, because it affects everything with timing, and in the end game it actually affects the actual output of the motor. So you want to make sure you're getting what you're paying for in one sense, and also that your tolerances for like valve clearance and everything else are not going to be out of whack based upon what you had kind of calculated when you designed the motor. So we're going to go ahead and go through that. I'll get everything set up, and the first part of it, we're going to be finding top dead center of the #1 cylinder. To find top dead center on your motor, you're going to need some tools. You'll need a cam degree wheel, a wire pointer, which is just a coat hanger I'm using that's twisted around and bolted to the block right here, pointing somewhat vertical in relation to the cam gear to start with. And you're going to need a dial bore gauge, either with a bridge or with an articulating arm to hold it in place. Right now I have my motor at TDC, and the way I did that was I've set at the height of my travel using my bore gauge. I waited till it stopped, and then I zeroed it out, and then I will move opposite 50 thousandths of an inch. Really tough because it's 45, but I think I started 5 in the hole anyway. So what I'm finding here is the dwell. I know I was at TDC, but I want to find the middle of the dwell point. So I'm at, we're going to call that 4 degrees. And then I'm going to go 50 thousandths in the other direction. This would be the direction of rotation clockwise. So tough with these sensitive tools. All right, there's 50. So I was at 4 degrees that way. I am at 4 degrees on the opposite side. So I know that if I roll to 0, I'm in the middle of the dwell. This actually worked out. I eyeballed it so well and just kind of guesstimated on how much rotation was left in the crank before it started down when I found my top point. So I will verify that with the, I'm going to roll this to 0 again, so I know I'm at middle dwell. And I'm going to verify that with my feeler gauges. In the video a couple prior, I checked my piston to deck height, and it measured out at 23 thousandths of an inch. So I'm going to go back to my feeler gauge, get my 23 thousandths out, line it up on the top of the piston and feel it perfectly flat. So it's absolutely 100% at TDC right now. You know, I've watched some of these videos, and I'm learning from other guys on the internet, and I've kind of come to the realization that finding TDC for the purpose of doing your cam timing is not really that critical. I'm not going to say I invented a hack or think that I've done something that nobody else figured out, because I am not that smart, but I'm going to show you how, after watching them and trying to put together their methods and duplicating them myself, I figured out how to check the cam profile with duration and lift. So that'll be the next part here. I'll get set up for that. To check my lift and duration, I've moved the dial bore gauge to the top of the block, and I have it resting inside the exhaust lifter. I'm going to start with that one. It's in the cup of the lifter. I've got a little preload on it, and I've zeroed out the bore gauge. And what we're going to do is rotate the motor until the exhaust lifter starts to raise, and then we're going to stop at 50 thousandths, because that's where the cam card or cam manufacturers take their measurements from for duration. So once we get to 50, we're going to reset our wheel, no matter where it is, to
0. And that's the difference from the other videos I've watched where they do this in separate steps. They do these individually based on the TDC from the piston number 1. That isn't interesting me so much. I just want the duration. So right now it landed at like 80 or 79 degrees. I'm just going to roll it back to 0 right there. And then I'm going to continue raising the lifter until I get to max lift. That's the number I'm interested in right now. And I think I'm about there. Yep. I've got max lift at 0.312 inches. Now 0.312 is just the lift of the lifter. It's not multiplied by the rocker arm ratio. So we need to do that. Go over to the board and make that calculation here. So I've got 0.312 multiplied by 1.5. Let's see. Gives me 0.468. So 0.468 lift on my exhaust side. And the cam card right here, where it says exhaust, is 0.465. So I'm really close on that. That's certainly within the margin of error. So I've got that number. Now for the duration. I've got my cam wheel, I've got 164 degrees. Now you need to take that 164 and subtract it. In fact, that doesn't sound right off the bat. That's going to be not enough lift. Let's see if I got that right here. Roll back and then approach it again from the other side. Here we go. All right, now it's starting to fall. Find that again. All right, we're going to call that 135 degrees. That's what I should have been looking at. I don't know how I got off on that. But the point at which, I think it was the dwell, I didn't roll it enough to take all the dwell out of it. But anyway, 135, that's the number I'm going to subtract from 360. It gives me 225 degrees. What does the cam card say? 224. The exhaust duration at 50 is 224. I came up with 225. Wire thickness, a little bit of movement in the gauge. It's a 5/10,000ths gauge, and you're measuring down to the 1/10,000ths really, and you don't have that much accuracy. So I'm going to take that. That's like right on. So that's worked out just fine. I'm going to go ahead and get my intake, lift, and duration and calculate that, and we'll see how the whole cam checks out here in a minute. Okay, I've taken my intake measurements. You can see I'm on the intake lifter right there. 2.295 or 55. I've got both, and it's within 5/10,000, so that's fine. So that's the number I'm going to use for my ratio with my rocker multiplication. And then 147 degrees is what I've come up with on my cam wheel, my degree wheel. We take those over to the board. So the 0.295 multiplied by 1.5 comes to 442.5 inches, and the cam card is 0.443. Spot on. The intake duration, 147 minus 360 minus 147 comes to 213. The card is 215. very, 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 very well within the margin of error. So that's how I have done my spec measurement for the cam. There's one more measurement to take. I'm going to take that real quick. I got to make sure I'm doing this part right, and then I'll film it. And that is going to be the installed center line to make sure that comes out to the 112 degrees the cam card indicates. There's one more measurement of the camshaft that we need to take, and that is the installed center line. To do that, you'll need to put the piston at top dead center, which my reference mark is still 0 for TDC. So I just rolled everything back and reset it from those initial measurements that I made. I still have the dial bore gauge set inside the intake load lifter and zeroed. Well, as much as the machine will let me zero it out, it's zeroed now. What we're going to do is we're going to go back all the way up to top lift of the lifter. So just rotate the piston. So you come back up on an intake stroke. Of course, I'm, again, completely out of phase. Here we go. So we're going to go back to top lifter here. And getting there. I think about got it. Yep. All right, so there's, take a little bit of the dwell out there. All right, so we're at the top of the lifter travel. And I'm going to read the cam measurement here, and it is 105 degrees. So I'm going to just write that here in front of you. So I have to go jump over to the whiteboard every time. So 105 degrees. Now, I'm actually going to go back the other direction, 50 thou. And I got to do the math in my head. That should take me to 0.2925. There we go. Take a little dwell out there. That measurement is 90 degrees. Now I'm going to go back past top lift on the downstroke of the load 50 thousandths. And that will take me to, should be 0.3025. Or thinking about that actually bass backwards, it's just back down to 0.2925 again, but just on the other side. There. All right, and I'm going to take that measurement, and we're going to call that 123 degrees. Write that down. Now we're going to add the 123 and the 90 together, and that gives us 213. Now we're going to split the difference of that because we want to find the center line. So half of 213 is 106.5. And I've left myself not a lot of tape to write that down, but 106.5 is what I've measured as the center line of my cam. And we'll go to the cam card. And the center line for it is right, where's my references? Right here by my thumb, 107 degrees. So the center line checks out too. I've now completed all my cam measurements, and it was a chore, but this is actually been at least educational for me. I've learned how to do it. I found a shortcut, a workaround that saved me a step in between measuring the lift and the duration. That every video I had seen on the internet did them as separate things, but that just didn't make sense to me, because why wouldn't you be able to do it all at once? I think the reason they didn't do that in those videos is they didn't want to throw off their cam wheel. They wanted to leave it referenced to TDC at 0. But that, when I first started, when I was talking about this, it's like that measurement, yeah, you need to stop at TDC at 0 on to figure the center line, but for lift and duration, it's just not that important. All that matters is the gauge and whatever reference numbers you come up on the wheel. So anyway, I think that was a little bit of a cheat, a hack. It works for me, and I'm going to keep using it. So, well, now that that's done, all I have left to do for the bottom end is get that oil pump pickup welded to the oil pump, installed. Then I can put the pan on, the front cover on, and I can seal this guy up for storage for maybe the rest of the year. I'll go ahead and tape off all the openings, make sure nothing falls in because the pan will be on it. You don't want anything in there because it's pretty much permanent at that point. So I'll get that done the coming week, and then just wait till probably after Christmas, after New Year's, get my cylinder heads and finish this guy off, and we'll take it from there. Thanks for tuning in. If you think I'm an idiot, subscribe for more idiocity. If you're learning something and you're enjoying it, subscribe for more of the same. Either way, it's fine. Y'all have a good night.